Welcome back to Teaching the Unteachables, where we dive into teaching and learning methodologies for professionals like you. This episode brought to you by Regal Rexnord Gentech Motors, the leading brand in electronically commutated motor technology. Learn more at regalrexnord.com. Well, hello, friends. Thank you for joining us once again. So we have a very special series to bring you, brought to you by our good friends at Regal Rexnord. Chris Mohalley, how are you, sir?
Very good, thank you.
So we're going to spend 4 sessions together. So we're going to do 4 different months, the first Thursday, the first show of the month, and we're going to dive deeper into ECM motors. So this week, we're going to talk about ECM constant airflow motors. The following month, we're going to dive a little deeper into ECM constant torque. Then we're going to go into ECM condenser motors, and then we're going to talk about the effects of airflow on all of the different ECM motors. And you go, well, why are we diving into ECM motors? Well, for me personally, it's a great topic to talk about, because when we start understanding motors in general and the differences between like permanent split capacitor motors and DC motors and ECMs in particular, it gives us a better understanding of technology, right? We're spending a lot of time talking about inverter technology and transitions into new generations of heat pumps. And if you have a confident understanding of ECM motors, you'll actually have a more confident understanding of inverter compressors. So Chris, thank you so much for joining us today. And let's dive a little deeper into ECM motors. All right, well, let's dive into, I consider you one of the motor masters of our industry, one of the lead technicians and trainers. And I always like to present that a lot of people don't understand that you can be a technician and not be a good trainer. You could be a trainer and may have never actually been a technician, but when you have the combination of the two of those, that's when the magic happens. And that's why I enjoy hearing you so much. You can speak the truth about what we see out in the field. So,
thank you.
Yeah. So, all right, let's see a little bit more about constant airflow motors.
All right, just an overview of, when we say constant airflow motors, the industry knows these motors by the term variable speed.
Yes.
And I don't like the term variable speed, but that's, once you get to know me, I have pet peeves just like everybody else. And
Right.
Variable speed's one of them, because if you take a single speed motor and you change its load point, its speed changes. So every motor is variable speed if you go by that definition.
Oh, absolutely.
So the reason I like the term that our engineers gave this motor way back when, constant airflow, is if you really just focus on the words, it's a constant airflow motor. It's kind of like if you focus on the words cruise control on your car.
Right.
When I set the cruise control, it maintains 70 miles an hour. When I have a constant airflow motor, I might be maintaining airflow, and that's exactly what the motor does. So you kind of get a better understanding of what the motor does when you think of when you listen to the words constant airflow, constant torque, constant speed. And so we'll start off with the constant airflow motor in this session, as you said. I do like to, for people that are maybe not as familiar with these motors, to know why. Being that it is our premium level product, it's typically found in your premium level HVAC equipment. So your 2-stage, which entered the industry back in the late 80s, same time ECMs entered the industry.
Right.
Wait,
what? 1980s?
Yeah, the late 80s. I may or may not have had a mullet back then.
Oh yeah.
I wish I still had some of that hair. So yeah, late 80s with 2-stage, and then that obviously progressed into 3-stage, and now we have modulating systems. That's where you're going to find the constant airflow variable speed motors. Not so much in your single stage equipment, and not so much in your not really at all in your builder's grade level,
Right.
Low level equipment. So what if you don't sell premium level systems, or you don't work on premium level systems, or a lot of them, you may not be as familiar with these motors as others. So I like to cover that early on. These motors are also what I like to call communicating. And I like that word because it immediately says something different than multi-tap, multi-speed.
Absolutely, it does.
You're not going to be moving wires from one tap to another to change the speed of the motor. You're going to be doing something else, because the motor is actually communicated with information from the OEM control board to the motor, which dictates how the motor performs. So
Absolutely.
to change the performance of the motor, you're going to be adjusting dip switches or jumper pins, or lately many manufacturers are moving to the fully communicated system where the thermostat's communicated, and all the menu selections and even fault codes are at the thermostat.
Absolutely. And we've talked about that quite a bit on the communicating systems, that we're typically using a variable 5-volt DC signal. So it's not like a light switch of 24-volt AC. No, like if you think about it like a standard thermostat or a PSC motor or a single or two-stage compressor, we're talking about a switch that applies voltage so that we have a load on something. When we talk about communicating, now we're talking about variable signals, just like we're talking about an internet connection. Any type of a serial signal where we use variable inputs and outputs, like all of our inverters are using pressure transducers and temperature thermistors, typically all from a 5-volt DC signal. A lot of our communicating thermostats. And on that 5-volt DC signal, we teach, well, we're not here to learn how to read the command that's going through it. We're learning to read that there is a command, that there is something happening there. And so that same principle applies when we get into ECM motors. And when we understand that, you can look at a motor now and be able to go, well, hopefully by the end of this class, you're going to look at that motor and you go, that makes so much sense now. And this is a fun topic.
Yeah, that's my hope. And actually I'll kind of give away the presents early. In my opinion, these motors are actually easier to work on than induction motors.
Heck yeah.
Because there's really only a couple of inputs and outputs to check. And when we get to the point of understanding that an ECM is a motor that's operated by a control, and that control is a circuit board, microprocessor, whatever. And I'm sure you've taught this or had somebody on your show that's taught this. Any control diagnostics is just what's the input, what's the output. And once you understand that, it becomes real easy. So the last bullet point I did want to mention before we move on is the constant airflow programming. Each of these motors actually has a constant airflow algorithm, because that algorithm has to understand airflow in CFM, has to understand static pressure, and it has to correlate that to torque and speed in the motor. And we're not going to dive that deep into the motor in this particular show. I mean, we could, but that would be a whole
1,000 foot to 100 feet would be good, because that way every technician, every instructor knows, okay, I didn't know much before, so we started here, and I got to here where I understand exactly. I'm not going to be an engineer. I don't need to know the 100 foot down into the algorithms. But if we wanted to go deeper, let me know in an email. Let us know in the chat. Maybe some other episode will dive deeper into algorithms and what those inputs look like to dictate the output. But for the most part, we're talking about troubleshooting and understanding how these things operate. And that we're definitely going to be able to do today.
Yeah, and the main reason I like to bring that bullet point up is, so I get asked quite often, can I take a ECM from a carrier, and it looks the same, has the same plugs, and put it in a train?
Right.
And I've even had people tell me, well, I've done that and it works. So what do you think about that? Because they'll hear me say, no, you can't.
You got lucky.
Yeah, well, it may be running, but is it running at the right airflow? Because
what the equipment is demanding or needs.
Right, because that might be like taking the computer chip out of a Chevy and putting it at a Ford. Well, if they were both V8s, it might fire the system, the motor up.
Exactly.
But is it running at the right horsepower? Is it running at the right oxygen levels? Blah blah blah. So you need to understand that these motors are actually engineered not just by us, but also by the end user, which my end user is the HVAC manufacturer. Engineered by them to match the performance of each system that they go into.
And some of those manufacturers have algorithms that work opposing from each other. So even if something happened to run when you get a call for G, as the speed is demanded to increase, the algorithms could actually be calculating the opposite direction and slowing a motor down. But that's a whole nother story. So it's crucial that we're matching the correct program, and it actually comes down to even model of the furnace, because the same model series of furnace, I need different airflows for a 60,000 upflow and downflow, 80,000, 90. So it's very specific for the actual controlling to get that airflow.
You bet. And you just covered one of my slides coming up. So nice lead in. No, I like lead in. They're good. So just to take a little step deeper into what is communicated means. Our motors, and so the first motor we ever built, and when I say we, the ECM technology was introduced by General Electric back in the late 80s. We acquired the 48 frame motor business from General Electric, including induction and ECM, in 2004-ish, rebranded it under Gentech. So that's why I keep saying we, even though it wasn't we. Kind of what is that saying? The royal we's?
Yeah.
I don't even know what that saying means. But if you go back to even the early 90s, all of our constant airflow variable speed motors have two plugs. They've got a line voltage plug and they've got a communication plug. And actually, from the early 90s all the way to today, there's really only two different motors. There's motors with a 5-pin line voltage plug and a 16-pin communication plug. And then you've got motors with a 5-pin line voltage plug and a 4-pin communication plug. And here's, I'll warn you, here's one of my really bad jokes. You know, what's the difference between the 16-pin motor and the 4-pin motor? 12 pins.
Yeah,
I told you it was going to be bad. I told you they're not good jokes. So, but the difference in all sincerity is the type of communication, right? So,
yes.
And anyone that's been to my class has heard me refer to these motors like printers. I use printer analogy: computer, printer, motor, OEM board, right? So, if anyone that's listening had a printer 15 years ago, right? You remember that the cable between the computer and the printer was a very wide cable called the parallel port, I believe.
Ooh.
A lot of pins in there, easy to bend them, not get them in the right place, right?
Yep.
That was the technology of the time, early 90s, when those 16-pin motors were designed.
Absolutely.
And I get asked often, well, why do you still make them then? I mean, the printers don't use that technology anymore. Well, we keep making the motor because the manufacturers they keep asking for it, right?
Absolutely.
So, but we did introduce the 4-pin motor, which is akin to a USB port. If you ever look at and I think I might have one here, if you ever look at one of your USB plugins, I know you can't see that, but if you look at your USB plug-in, inside there are 4 pins. And those 4 pins are communicate, transmit, power, and common. So when you want to communicate with something, you really only need 2 wires. So for the OEM board to talk to the motor, I only need 2 wires to come in and send information to the motor. But if I want the motor to provide communication back, you know, I'm running, I'm here, what speed I'm running, then I need a transmit channel back. So that's how the current 4-pin motor works. So when you look at the 4-pin motor, you know, again, trying to make things simpler in your minds, not those big scary ECMs.
That's right.
Just think about a motor with a 5-pin plug and a USB port. Because that's really all that 4-pin plug is.
Yeah, absolutely. Well, and like when we talk about things like pressure transducers on a inverter system, or even your pressure transducer that is on your digital manifold gauges, you know, we've got a hot, we got a common, and then we have a variable coming back. So when we start getting into serial communications, that's typically what we're talking about, is we're talking about supplying a constant and returning some kind of a variable so that we can talk both ways. Sometimes we have the extra where we can variable forward and variable backward. We're just talking back and forth on a simple wired connection.
Yes, sir. And a little later, we'll talk about what some of those voltages are, because obviously you're not going to have an oscilloscope or a device that can actually read that binary code. But you can measure most of that communication with either AC or DC voltage settings on your meter.
Nice. All right.
Yeah. So what does the communication do? The communication is the on-off command for the motor. The line voltage to an ECM is connected continuously. And we do that on purpose. And I didn't take my motor apart, but I'll do it while I'm talking. Do you have one taken apart there?
Yeah, absolutely. Let's say, Daniel, we'll throw that camera.
You got the control off already?
Yeah. Okay. No, but I'll do that.
No, you got one right there. Right there next to you. You got a control.
Yeah. So we got
both. If you look at that control that's next to you there, inside, you're going to see some little capacitors. Look at those cute little guys. Aren't they adorable? Those capacitors are about 1,000 microfarads a piece. So they carry a punch. So the reason I bring this up is I get asked all the time, why is the motor continuously powered? Why not switch the line voltage on and off instead of switching the communication?
Sure.
And it's because of those capacitors. Every time the line voltage is turned off, the caps discharge.
Discharge it.
Every time you turn the motor back on, they have to fully charge, and they draw a significant inrush of power to do that. So we leave, and that would cause the manufacturer's circuit board to have a more robust relay if we were to be turning that line voltage on and off. So
absolutely, controlling that load, that inrush load. Yeah,
exactly. So we leave the motor powered all the time, and again, relating it to something like the printer or even your home stereo, or I mean, do you unplug your microwave when you're done working it?
No, it stays energized all the time.
You press the on-off button, and that sends the command to the devices to turn on and off. So that's why we do it that way, and the communication controls that. But it also controls the communication, also controls the airflow the motor is going to operate at. So if the dip switches, you can see the square around the circuit board on the screen. If the dip switches are not set correctly, even though the motor might turn on, it might not be producing the right airflow. And the only way to adjust that is to change the communication coming to the motor.
Right.
Because I have been asked, so what if I take the wires out of the 16 pin and move them around? Well, usually that's going to cause the motor to not run because you've rearranged the communication and it's not going to like that.
Right.
So it's not a tapped motor. You're not going to change speeds by adjusting the wires.
Exactly.
You're going to adjust the dip switches on that board on the screen, which is going to change the communication coming to the motor.
Sure, it's going to change the voltage or the pulse width modulation of that voltage so that it gets an idea what the command is.
Or the serial communication if we're talking about the 4-pin motor.
Exactly.
Yep. The last bullet point I did want to touch, and where I think we're going to get it on the next page as well, is you are going to need the OEM manuals to adjust airflow. Unlike popular belief, HVAC systems don't come from the manufacturer perfectly set up for every home they're going to go into. Yeah, I know. It's a surprise.
They're a drop and go package, aren't they?
Plug and play, right? You just plug them in and they play.
These things are so smart. I don't have to do anything. These new variable technologies and communicating thermostats, I just hook them up and go.
They are getting smarter, especially the ones with communicating thermostats. The thermostat can talk to the outdoor unit and actually set that airflow. Yeah. But you will need the manual for some of the settings. I carried books and books to have the manuals. Today, you're going to get them all on your phone. You're going to Google a model number and probably find it. But become that technician. Sorry to take a segue here.
No, absolutely.
Please become that technician that on every job pulls up the manual and checks to see if the system has ever been set up properly and measures the airflow. You will just be amazed at how much better systems will run, how many fewer repairs you have. Customers that'll tell you, I never knew that the air coming out of that furnace could be warm. Yeah. I thought it was always, it's a high efficicy. They told me it would be cold.
High airflow, high everything.
With one dip switch setting, all of a sudden, hey, that feels good. So there's my punch for the industry.
No, absolutely. I've seen it so much when I was doing technical support calls that, I would do site visits. First the call is, all right, let's verify that we got proper airflow. Oh, yeah, I got proper airflow. And the most common call that I had on my constant airflow motors is that they were tripping out on blower fault codes. And the beauty of the communicating system is that it can send a signal back to the control board when it senses high temperatures. And where do those high temperatures come from? Well, they come from excessive load on the motor. And it is almost every time I would find excessive static pressures. And we'll dive into that later on, probably episode 4, when we get into how airflow affects them. But we always have to remember that a motor is a motor, and excessive pressures are always going to have negative consequences. So they can fix themselves a little bit, they can tweak, but they definitely can't fix bad habits.
Yep. And we will touch on that just a little bit here for those of you that are going, I was really hoping they'd talk about that today. We will talk about it a little bit.
You got to come back for more. That's all your friends too.
We'll tease them. Yeah,
that's right.
So, a big part of the setup is simply the cooling and heating airflow. Those have to be set correctly. Beyond that, everything else is creature comfort. But these systems truly do have some pretty amazing creature comfort abilities now, and not just comfort, but even I live in Wisconsin, right? High humidity for us is when the windshields are wet in the morning and we freak out because the dew points are high. And for those of you in Louisiana or other humid markets, you just laugh at us because that's your wintertime conditions, right? My peak summer. But there are truly some amazing features on these new systems that can adjust the not only the amount of air, but the time that the airflow runs at certain levels to get more latent versus sensible removal out of the coil during a typical cooling call. So besides the fact you can have first stage, second stage, you can also then have a first stage and second stage that are running at part airflow for a certain amount of time and get more latent removal. And then, of course, because the manufacturer has engineered all this in, you can get all that without having to worry about freezing the coil by just dropping a speed. And so those are all the other functions there. Some of them are simple selections where you say, hey, I want more dehumidification, or some of them are more sophisticated where you can pick a profile that matches your market, and some of them are even more sophisticated where the unit will look at the humidistat or humidity sensor in the
That's right.
thermostat on the wall, and it will gauge whether it needs to go into dehum mode by what's actually happening to the conditions in the home.
Boy, that's a whole nother topic. That could be a 5th conversation right there, because
You-
I can preach all day long on proper airflow for dehumidification, especially when it comes to inverter operation. So,
we would need to bring in Rick Tinsel for that one. So
okay,
he's the expert on that. But yeah, so the thing to keep in mind is it's not, the cooling and heating airflow are not always going to be properly set up for every job the unit goes into.
Right.
But all of those other settings, the creature comforts and the dehumidification, they're going to be set at a default setting for general USA, not for Fargo, North Dakota compared to Miami, Florida, which are going to be drastically different climates. So you'd have to go in and adjust those. And my plug as a former technician, maintenance technician, service technician is, this customer paid for a premium level system. They're not getting a premium level system if we don't set it up properly. And each job is different. I mean, even here in Wisconsin, I would set up systems for maximum dehumidification. You go, why in Wisconsin? Well, I've got a family that never opens the windows. They're asthmatic, whatever. The windows are always going to be closed.
That's what they're looking for.
Multiple people living in the house. Maybe they're, and I hope I don't get in trouble for this, maybe they're Italian and they cook a lot.
Right.
That
makes sense.
There's going to be a lot of moisture in the house and a lot of showers in that house. And I want to get that humidity out of the house. So there are reasons to set those settings, not only based on region, but also by the consumer's preferences. Yeah.
All right, everyone. Well, thank you so much for joining episode 1 of a 4-part series. Next month, we're going to be diving into constant torque motors. And you're going to go, wait a minute, did we just talk about ECMs? And we'll go, no, we're going to talk about their cousins, the constant torque versions of those.
Yes, we are.
All right. Well, thank you so much, Mr. Mohalley. And we look forward to seeing all of you again next week on Did You Know the ESCO HVAC Show? Tell all of your friends about the great stuff that we're doing over here. Subscribe to the channel, turn on notifications. That way you can join us for these live conversations with the coolest educators you've ever met in your life.
I've never been called that, but thank you.
Absolutely. All right. Bye, everybody.